Object-oriented programming is a core of Java programming, which is used for designing a program using classes and objects. OOPS can also be characterized as data controlling for accessing the code. I am Balaji Chandrasekharan. Today, I'll be discussing the object-oriented programming concepts in Java. Class is a blueprint or template for creating objects. It defines the properties, fields, and behaviors, methods, that the objects created from the class will have. In object-oriented programming, we often model real-world entities as classes. This approach helps us represent and manage complex systems in a modular and organized manner. Each class serves as a blueprint for creating objects, instances, that encapsulate both data and behavior relevant to the entity being modeled. For example, the car class represents a vehicle with properties like make, model, year, and color, and behaviors such as start engine, accelerate, and brake. A person class can represent various properties such as name, age, and behaviors like speaking and walking. An object in Java is a basic unit of object-oriented programming and represents real-life entities. Objects are the instances of a class that are created to use the attributes and methods of a class. A typical Java program creates many objects, which, as you know, interact by invoking methods. An object consists of state. It is represented by attributes of an object. It also reflects the properties of an object. Behavior. It is represented by the methods of an object. It also reflects the response of an object with other objects. Identity. It gives a unique name to an object and enables one object to interact with other objects. Objects are created using the new keyword followed by the class constructor. Instance variables are the attributes that belong to an instance of a class. Each object has its own copy of these variables. Instance methods are the functions defined in a class that operate on the instance variables. Constructor is a special method called when an object is instantiated. Constructors initialize the object's state. The this keyword is used within a class to refer to the current object. Object members, variables and methods, are accessed using the dot operator. Java automatically manages memory through garbage collection, which deletes objects that are no longer referenced. Inheritance is a mechanism in Java by which one class is allowed to inherit the features, fields and methods, of another class. We group the inheritance concept into two categories. Subclass or derived class or child is the class that inherits from another class. Superclass or base class or parent is the class being inherited from. When a class inherits from another class, it means the subclass is a type of the superclass. The is a relationship helps in promoting code reuse, establishing a hierarchy, and facilitating polymorphism. The extends keyword is used to inherit from a superclass. As in the example, car is a vehicle since the car is a subclass of vehicle class and vehicle is the superclass of car class. The super keyword is used to refer to the superclass's methods and constructors. Polymorphism is derived from two Greek words, poly and morphs. The word poly means many and morphs means forms. So polymorphism means many forms. There are two types of polymorphism in Java, compile-time polymorphism and runtime polymorphism. We can perform polymorphism in Java by method overloading and method overriding. Method overloading in Java allows a class to have more than one method with the same name, but with different parameter lists. In the provided code, both methods are named add. This is the key aspect of method overloading. The first add method takes two int input parameters. The second add method takes two double input parameters. While the return type can be different, method overloading is primarily determined by the parameter list, not the return type. Method overloading is resolved at compile time. The Java compiler determines which method to call based on the method signature, the method name and parameter list. When you call the add method with int arguments, the compiler calls the first method. When you call it with double arguments, the compiler calls the second method. Method overloading is a powerful feature in Java that enhances flexibility and robustness in programming, allowing methods to handle different types of data seamlessly. Method overriding in Java is a feature that allows a subclass to provide a specific implementation of a method that is already defined in its superclass. This is one of the key ways to achieve runtime polymorphism, enabling different behaviors in a subclass while preserving the method signature. In the provided example, the animal class is a superclass and has a method named sound. The dog class extends animal and overrides the sound method. This method prints a specific message indicating that a dog barks. When sound method of the animal object is called, the sound method of the animal class is executed. When sound method of the dog object is called, the sound method of the dog class is executed. Method overriding is resolved at runtime. When a method is called on an object, the JVM determines which method implementation to execute based on the actual object's class, not the reference type. This demonstrates how method overriding supports polymorphism, allowing the same method call to produce different results based on the actual object type at runtime. Encapsulation is the concept of bundling data, attributes, and methods, functions, that operate on the data into a single unit, called a class. Encapsulation is to make sure that sensitive data is hidden from the users. Encapsulation is a way of hiding the implementation details of a class from outside access and only exposing a public interface that can be used to interact with the class. In Java, encapsulation is achieved by declaring the instance variables of a class as private, which means they can only be accessed within the class. To allow outside access to the instance variables, public methods called getters and setters are defined, which are used to retrieve and modify the values of the instance variables, respectively. By using getters and setters, the class can enforce its own data validation rules and ensure that its internal state remains consistent. Encapsulation is defined as the wrapping up of data under a single unit. It is the mechanism that binds together code and the data it manipulates. Another way to think about encapsulation is that it is a protective shield that prevents the data from being accessed by the code outside the shield. Data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. The abstract keyword is a non-access modifier, used for classes and methods. Abstract class is a restricted class that cannot be used to create objects. To access it, it must be inherited from another class. Abstract classes cannot be instantiated and can include abstract methods, without implementation, that must be implemented by subclasses and regular methods. Abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the subclass. From the given example, it is not possible to create an object of the animal class. Another way to achieve abstraction in Java is with interfaces. An interface is a completely abstract class that is used to group related methods with empty bodies. To access the interface methods, the interface must be implemented, kinda like inherited, by another class with the implements keyword, instead of extends. The body of the interface method is provided by the implement class. Like abstract classes, interfaces cannot be used to create objects. In the example above, it is not possible to create an animal object. Other than the default and static methods, interface methods are by default abstract and public. Interface attributes are by default public, static and final. An interface cannot contain a constructor, as it cannot be used to create objects. Java does not support multiple inheritance, a class can only inherit from one superclass. However, it can be achieved with interfaces, because the class can implement multiple interfaces. To implement multiple interfaces, separate them with a comma. Classes and objects are the two main aspects of object-oriented programming. Encapsulation, inheritance, polymorphism, and abstraction form the foundation of object-oriented programming and are essential for creating modular, reusable, and maintainable code. We've reached the conclusion of this session and look forward to seeing you in our next one. We hope you've enjoyed the video. Don't forget to like, share, and subscribe. Thank you for watching my video.